Here's a quick run through of how to use the LRC circuit spreadsheet. So you're going to start off by in the top corners putting in the values of your circuit components. So it was a 7 ohm resistor, a 290 microfarad capacitor. We need to put that into farads. So it's going to be 290 times 10 to the minus 6. So I'm going to do E minus 6. And you see that's changed that to 2.9 times 10 to the minus 4. And then the capacitance was 1.5 millihenries. So I need to turn that into henry. So it's going to be 1.5 times 10 to the minus 3. So I'm going to do E minus 3. And hit enter. And then the voltage on the generator was set to be 10 volts. Alright, so now I've got all those values. And I've gone ahead and I've put in some values for the number of divisions and volts per divisions. Then for these colored columns, all I'm going to do is I'm going to use the appropriate equation at the side that matches the color. So the volts, the total voltage across the resistor is the number of divisions times the volts per division. So the first one is going to be column B, row 7, times column C, row 7. So I'm going to put it equals B7 times C7. And then again, click on that, grab that black corner, and drag it down to the bottom. So it's calculated all the voltages. Alright, next one is this peach colored column, which is the current through the resistor. So the current is the voltage divided by the resistance. And if we look up here, my resistance is 7 ohms. So it's just going to be equal to the voltage, D7, divided by my resistance, which is 7. And again, drag that down. Okay. Next thing is what is the inductive reactance. So that's 2 pi times the frequency times the inductance. And this equation looks a little weird. Let me just stretch it out so we can see it a bit better. Okay, so it's 2 pi times F times L. So it's going to be equals 2 times pi, and I have to type in, so I usually do 3.14159, times the frequency. The frequency is over here in column A, so A7, times L, and L is this reactance here, this inductance here, and I need to put in the number, so I'm going to put in 1.5 E minus 3. I can't put the cell number because otherwise when I copy it down, it's going to go down the row of cells. So I have to put in the actual number for the inductance. And I grab this corner and drag it down. Alright. XC is 1 divided by 2 pi FC. So I'm going to do 1 divided by, and I'm going to do open parentheses, because remember I have to divide by everything down there. So 2 times pi, 3.14159, times the frequency. Frequency again is A7, times my capacitance. And if I go back up and look at my capacitance, that's here, 2.9 times 10 to the minus 4. So 2.9 E minus 4. Close my parentheses. Oops, I forgot to put an equal sign. So let me go back. I'm going to click on that, and then I'm going to go right at the very front of the formula cell. So I'm going up here, type in my equals. Okay, there we go. Now I've got a number. And again, drag that down. Alright, we're getting there. 2 more columns. Alright, Z, the total impedance. Impedance is square root of R squared plus XL minus XC squared. So R is a constant. My R is 7. XL and XC change. XL is row F, so column F, and XC is column G. So we're going to type that in. So we're going to do equals square root, and XL is SQRT. I'm going to open the parentheses, and then the first thing is R squared. So R is 7, so I'm going to do 7 squared plus, now open parentheses, XL is going to be this column here, F7, minus XC. XC is going to be G7. And I'm going to square that difference. So I'll close my parentheses and square it. And now I have to finish off my square root, so I put another closed parentheses, hit enter, and then I'm going to drag it down. All right, one more thing. What's the theoretical current? The theoretical current is going to be the voltage on the generator, which is set to 10 in this case, divided by Z, which is column H. So I'm just going to put equals 10 divided by, and I'm going to divide by Z here, H7. All right, and then drag that down. All right, so now I've calculated the current, the theoretical current, the experimental current. I've calculated the inductive reactance, the capacitive reactance, and the impedance as a function of frequency. The two graphs are in the two other tabs at the bottom. So if I look at the resonance plot, I have here, this is my measured current and my theoretical current, and here my frequency doesn't go out far enough. This should go out to 600. So let me change that. All right, why is that not plotting it? Just a second. I will fix this in the graph that you get. So let me see. So I need to go down to 32. Okay, so you should not have to fix that. So I need to go 32 and 32, and you will not have to do this. Okay, and then we'll fix the blue line. That also needs to go to 32 and 32. Okay, so the blue is the measured current, the red is the theoretical current, and you can see that the two curves pretty much lie on top of each other, so you can see that the data is good. Right, the other one is just going to be a graph of the inductive reactance, that's the blue line. You can see labels, the capacitive reactance and the impedance. And again, this plot is not going all the way out, so let me change that. Right, so you're getting a little bit of extra instruction on how to fix some things in Excel. So I'm just clicking on the specific curve that I want to fix. And I'm changing the data. Okay, and we need to fix the blue line. Let's go 32, 32. All right, so that's made my video a couple minutes longer. All right, so now you can see that you have the green curve, you have the red and the blue curves, the inductive reactance and the capacitance reactance crossing each other. So that value there should tell you about where your peak should be, where those two guys cross each other. You've got your first graph of measured and theoretical current, and you've got all your values. And that should be all that you have to do to answer all the questions relating to the lab.